Hi, I'm Jing. I'm a second-year PhD student from UC Santa Cruz. My advisor is Professor Peter Avero. My work mainly lies in distributed tracing and fault injection. This paper briefly discussed the pros and cons of the existing tracing frameworks and fault injection approaches, respectively. And we proposed a generic approach that performs both tracing and fault injection functionalities based on microservice-level communications. Since communication is on the critical path of distributed applications, every single inbound and outbound message should go through serialization functions. Serialization functions lie between the service handler and the frameworks, and they help serialize and deserialize messages. We categorized how the frameworks invoke these three functions, including two serialization functions and a service handler function, into four design patterns. The main criteria are whether these three functions are executed in the same thread. Figure 1 shows two of the design patterns where all of these three functions are executed on different threads or on the same thread. Generally, to link the inbound message, the service handler, and the outbound message, frameworks should perform context propagation mechanisms to pass essential metadata of the messages through these three functions, as shown by Figure 2, depicted by arrows 2 and 5. Our work takes advantage of the existing context propagation mechanisms to capture message-level events and inject faults transparently with low cost. We deploy our approach on a microservice demo application called HipsterShop. As a tracer, our approach outperforms Jaeger by cutting half of the overhead, and as a fault injector, our approach can trigger a new important class of bugs that haven't been reached so far to the best of our knowledge, namely temporal fault injection, TFI. That's all for my talk. Thank you for listening.